One way that something could do rootkit-like interception or man-in-the-middling of system in order to either change data or capture data is by registering as a filter driver, basically just having a kernel module and getting themselves put into this device object chain, targeting some particular device object that they know data will be going towards that they care about. So in this case, it was the thing like they knew the keyboard class 0, there will eventually be keystroke data going up and down that chain. So they register themselves as an upper driver for that, upper filter driver for that. All right, so the second place where an attacker can register as man in the middle, rather than adding themselves into this chain explicitly, instead they can just modify this table of function pointers, which is associated with each of these driver objects. So this table of function pointers that's attached to the driver object structure, it's basically a list of what type of IRPs this driver wants to hear about when they're coming down the chain. So the way it looks is there's this driver object structure. This is the actual driver object, and then there at the end there's this major function array. It's an array of 28 function pointers, and for each of those it's basically a function pointer that says if a particular type of IRP is coming down that chain, then call my driver at this particular function. And so, you know, one way an attacker can get that is just adding themselves in and calling into the function in their driver object. And another way is instead of adding themselves into the chain, just find someone already in the chain at the level that they want to be at, and instead just rewrite that function pointer so that it calls their functions instead. So in this particular case, you know, an attacker, rather than registering above keyboard class 0, you could just wait for the stuff to come down to keyboard class 0 level and just fill yourself in at that little array of function pointers so that when this keyboard class driver would have found out that, hey, there's, you know, a packet coming down or a packet coming up, it can just fill itself in at this function pointer table and hear about it that way. All right, so that's the structure definition with all that attached function pointers. And then this is the structure definition for the device object, so I just want to make this kind of concrete here. So this has this little array of function pointers at the end, a driver object. The device object, as I said, it's kind of just to create that linked list in order to see the associated things. So that's why there is, for instance, this one pointer to a driver object. That's that sort of horizontal pointer that we said. One device object horizontally points to a driver object. And then there's these other things like next device and attached device that corresponds to links within that chain. And then this is the actual IRP struct. I just put it in there for, it's not particularly useful. It doesn't show you where that blob of data associated with it is, but there it is. I guess the only reason I put it in there is that if you look at the wdm.h file, it's the Windows driver model header file used for kernel developers. That has actually comments in like pretty much every single one of these things where it's describing what they actually do. And the thing is, even in this, the IRP, just making a quick reference back to that kernel object hooking that we were talking about before. So we know this IRP is like a blob of data that's kind of going up and down this stack conceptually. Even in this, there's things like cancel routine, which are function pointers in here, where, you know, if this IRP is going down but it has to be canceled, the IO control manager is going to call that function. Is there another one in there? Doesn't look like it. But for instance, that cancel routine would be an example where an attacker, if he, you know, knows where these IO request packets are, he can go in and fill in this cancel routine, calling his cancel routine instead. Maybe he gets some benefit from that. Maybe he doesn't, but that would be an example of kernel object hooking. So as we just said, that major function thing at the very end of the driver object is just an array of function pointers. So instead of adding yourself to the chain, you can just hack yourself into someone else's function pointer table who's already in the chain. So this is a list of the different types of IRPs that can be going up and down the chain. So there's things like create or close or read or write or directory control. So like I said, the point is these are supposed to be sort of abstract packets that are moving throughout the I/O request system. It could be on things like, file system access. So the read and write, that obviously is looking at, I want to send data to the thing. I'm writing this blob of data, send it to the hard drive. Right? Read is I want to read in this blob of data from the hard drive. Directory control is what's used actually for listing directories if you're listing something on a file system. So that's relevant just for, hiding files on a file system. But all of these potentially have utility for attackers. Just really depends on what they actually are trying to hide or intercept or monitor or whatever. So this is just, I posted the entire thing so you can see the names of the type of, quote, objects or I/O requests that are going on. So at this point, I could show device tree, but I don't have it on my USB token to put in there. And unfortunately, you have to register to download it at OSR.com? OSRonline.com, actually. Yeah, there it is. Unfortunately, you have to register to get this, so I'm not going to show this. And actually, I've been kind of going back and forth on whether I care to show this or not. The issue is the way that this shows change is sort of not useful. It's sort of useful. It's sort of not useful. The issue is you see right here where there's this DRV. These are a bunch of driver objects right here. The problem with this tool, the reason I like it because it shows you information that it's hard to get through other things, but I dislike it because it won't show you a complete chain, whereas something like WinDebug will easily show you a complete chain, and I can't remember if VirusBlock Ada does. I feel like it doesn't actually, but Bill, over to the board. So we said there was control to cap and keyboard class, and there was I-8042, there was whatever's there, ACPI, I think. Looking at this thing right now, for instance, I have it expanded here where it says driver I-8042 PRT, and then there's two devices associated with that. So for that particular driver, it exports, it created two devices. One of them is this unnamed thing right here, and another of them is, I think, another unnamed thing. This expansion is saying this driver created two devices, and for this second unnamed thing, there is attached to that keyboard class 0 device, and attached to that control to cap device, stuff like that. The problem is this is essentially showing you this part of the chain right now, right? It's saying this is associated with that chain. But that's not giving you the complete chain. In order to get the complete chain, you have to go down to ACPI and find the particular, empty device that points at that, that points at that, that points at that. In WinDebug, if you look anywhere on this chain, it'll just give you the entire chain. So I have the commands, and I'll show them in a second. But to me, it's just much more useful to say, what does the entire chain look like, right? I said what we care about is knowing who should or shouldn't be in this chain. On a, on a quote normal system, MITRE system or whatever, which entries do we expect to be in this chain? So certainly we don't expect control to cap, but maybe we consider that a legitimate thing, close enough to legitimate as long as, the driver is signed or something like that. So if we went and looked on someone's system and we saw control to cap, we wouldn't be too worried. But if we see something where we have no idea what it is, that's when we start to care. But with this device tree, if you happen to just expand to the wrong thing, then you're missing, lower portions of the chain. Also, the other problem is it doesn't actually show the function pointer addresses in each of those device objects. So it'll say which things it actually listens to. So this will say, oh, okay, well, right now I have it clicked on Hacker Defender, and it says Hacker Defender has registered callbacks for, IRP create, close, read, write, device control, other things. And here we go. I mean, it's nice at least that this thing can even see the Hacker Defender thing, even though it's hiding itself. It's hiding file system stuff. It's hiding registry stuff. But it just doesn't assume anyone's going to come in at the level of looking at driver objects and device objects and stuff like that. So This tool is not in any way trying to get around rootkit hiding techniques. It just automatically can see that driver object there. So that's there. You could maybe play with it. I think we'll have other tools that are better. But I guess here again, there's an example where you could maybe pick out something like this control to cap and CTR1, 2 cap. You know, you'd say, hey, it looks like one of those two is impersonating the other. I don't know which is which, but someone's impersonating someone there. But the question is, you know, are you going to really look through all of these devices and go with manual human inspection? That's probably not the best way to go about it. All right. That's just a little bit of device tree. Here is like some WinDbg commands. You can play with these later. But like I said, the thing I like is that when you do this device stack command, you get the entire device stack. It's saying, and I should say that this was taken on a system that didn't have control to cap running at the time. Otherwise, you'd see control to cap in there. But ACPI, I8042, keyboard class, and anything else in that chain is going to be printed out there. So I'm going to, and I'm going to pull all these WinDbg commands out to the end and say, like, here's a reference. Here's how you look for SSDC hooks in WinDbg. Here's how you look for, you know, IRP hooks and all that sort of thing. I'm just in the middle of that at the moment. But here's how you print the entire IRP table. So you say for all of those 28 things at the end of a device object. So if this was my, driver object. If this is the address of my driver object, plus 38 equals the major function entry. And then all of those 28 things at the end, this is WinDbg saying, you know, what is the symbol that's associated with this particular entry? And so in this particular case, it all works. Yeah, it's reasonable. This, well, you wouldn't know unless you were looking at these other things, but this is for the I8042 driver, PRT driver, this is the major function table associated with it. So essentially this is, I just printed out all of that stuff right there. Good. I was just in WinDbg and I dumped all that out for this particular device. Now, you saw a few of these pointed back in